This week we're going to talk about Linux system monitoring. But before we do that, I would like to cover a topic that a few of you have had questions about now that you're working on your projects. And that deals with the environment variable path. So to list all your environment variables, you can run the command env, and you could env list all of the variables, and then you can actually uh, grab particular ones. If you're looking for path, you would do m5 grab path. Okay, and then here it shows uh, my uh, the variable path in my system. Okay, and basically what this is these are the directories where when you run a command, it looks for executables for that command executable in these directories. So if I run the command ps, uh, it will look in any of these directions and see if it can find an executable by the name of ps. And if you want to know where ps is, you could do which ps, and that tells you it's in bin ps. And the reason it found it there is because the bin directory is part of my path variable. So if you install a program on your machine and you want it to be um, and you want it to run, when you just run the name of the executable, you need to make sure that you add the path here into this variable where you've installed that executable. And if you want it to run, and this works by order. So if it finds it here in user curl process bin, then it will run whatever executable is there. So if you have two of them, make sure that the one you want running, the path variable has it before the other one. Uh, to set it up in your to set this path variable, you could just edit the .bash rc file. So you could bi .bash rc, and here you could just put path equals and put all of the different paths. So that's how you would configure the path on your system. Now let's talk about system monitoring. When it comes to system monitoring, as I explained in the notes, there are different resources you can monitor, and some of these are CPU, memory, bandwidth, and disk space. So first, I'm going to list some of the utilities that you could use to monitor CPU. The simplest one is PS. So you could do PS minus AUX, and this will list you all the processes running on your system. Okay, and it gives you the PID, how much CPU, how much memory they're using, and what the processes are. This is one tool. Another one that I like a lot better, which I use a lot, is top. The top utility basically lists you all the processes running, and it tells you the user, tells you how much CPU, how much memory, and how much time it's been running. And here it gives you a lot of good information. It gives you information about memory, so how much memory is free, how much use, what's the total amount of memory on your system. It talks about all the swap information, so your secondary storage information. Here it shows you all the CPU statistics. And the one that I use for CPU, which I really like, is this load average. So these are basically how many processes are waiting on the run queue to execute. And this is over 5, I think it's 5, 10, and 15 minutes. So this is what it is right now, and this is where it was 15 minutes ago. So you really want this load to always be under 1. Anytime it's over 1, your system is it's going to be slower, and there's going to be processes waiting to execute. Um, the nice thing about top is that you could sort it. So you could do, if you type C, it shows you the entire command of the process. And you could do Shift P, so capital P, uh, sorts it by CPU usage. So this is the process that uses the most CPU right now. In my case, it's top, but it refreshes every 5 seconds. So here, after 5 seconds, now it says SH, for example. Now you could sort it by memory by doing capital M, Shift M. And here it shows me that MySQL is the process with the most memory utilization, which is about 5.6. So top is a really nice utility, and you could do a man on top to find out more about it. Another important tool for monitoring both memory and CPU is the VMstat tool. So you can run VMstat, and it shows you memory statistics and CPU statistics. And you could do VMstat 5.5, and this will update every 5 seconds. Okay, so every 5 seconds it shows you. Here it tells you the number of context switches for the CPU, and here it tells you swap statistics, IO statistics, and memory information. Okay. There's a similar tool which is useful for disk type information, and that's the IOstat. This is for IO stuff, so you could do IOstat 5.5, same as the other one, same as VMstat. And basically here it lists all the devices on your system, and it tells you information about blocks that are being written and read, and also it gives you CPU information. So how much of the CPU is spent by the system and by the user, and if there's any waits. And here it looks like the system is pretty much idle, so that's always good. You want to make sure your idle is high, and there's not a lot of read or write information that's occurring on the system right now. The other tool is for disk is df, so you could do df minus h, and you've already seen this. This tells you your disks and how much data is in use in each of the disk partitions. Finally, the SAR command shows you CPU information for your system. Here it tells you your kernel information, and here it tells you by time every 10 minutes all the CPU information. So it looks like, for example, this system has been pretty much idle except for this one time when it was using 50% of the CPU was being used by user and nice processes. A lot of these utilities are part of the sysstat RPM, so make sure you have installed this utility RPM-QA 5 sysstat. And this sysstat RPM contains a lot of the IOstat and VMstat executables. And another thing it does is it runs a cron job. So if you go to etc cron.d, you can see that there's a sysstat cron job. And basically what this does is it runs a cron job that keeps the information about, it basically runs that SAR command and keeps text files. I think it does one every day, and it keeps it under var log sa. And if you look at here, it's by date, so this is yesterday's SAR file, and this SAR file contains all the information, all the system monitoring information for all of the resources, basically CPU, memory, bandwidth, and disk information. So here it tells you processes per second on the CPU every 10 minutes, number of context switches that the CPU did. Here it tells you the idle times and the number of interrupts per second. This is memory information, the swap ins and swap outs. Looks like we didn't have any swap ins, so that's good. And then here's some disk information, information on the network interfaces, so number of packets that came in and went out on the different interfaces, and really a lot of information. Here's disk information and a lot of disk information. So really, um, it keeps one of these SAR. It runs that cron job, which basically creates these SAR files, which are based on the data that it collects on the SA files, and it keeps them on a daily basis. And I think there's a job that actually cleans them every 30 days, so it will keep 30 days worth of this data. So actually, you could go out there and get a graphing type of utility and graph and see how your system is performing. Um, so make sure you install that systat utility RPM. I think you installed it already in a previous assignment, but if it's not there, make sure you reinstall it, because if your system is not performing well, you could go to the SAR file and look at the times and see what happened at each time and see what caused the system performance. Um, Now, the next thing I want to do is talk about the SNMP uh, protocol, which is the Simple Network Management Protocol. And a lot of servers and network equipment and printers, they keep a lot of their operational statistics in what they're called object identifiers, or OIDs. And you can remotely retrieve these by using the SNMP protocol. There's three versions of the SNMP protocol, and the simplest one is version 1. And it was designed to be a protocol basically to provide device statistics and error reporting without using too many resources. In version 1, security was limited to these community strings, which basically is sort of like a password that tells you where basically the name of your community, which is like your particular server information, and an access on version 1 is basically based on the IP addresses of the server you're trying to query. All of the information in SNMP version 1 was not encrypted. Now version 3 of the protocol is a lot more secure, and it encrypts all the data and uses username and password for client authentication. Like I said, in version 1, you just use a community, which is uh, basically all the security you have there. So let's take a look at the configuration file for SNMP in Linux. This is found under etc SNMP, and the file that's important here for configure SNMP is the snmpd.conf. So let's look at this file. Um, there's a lot of information here, but really, to make SNMP work on your system, the only thing you need to do is set your community. So the command, the parameter here, ro community, and then give it a name. This could be anything that you like. In my case, I've used CSE570E. It's really, I said it's a password, but it's really not a password. It's just a way to identify the SNMP instance running on your hardware device. And multiple hardware devices can have either the same community or a different one. It really doesn't matter. But when you actually query using SNMP, you're going to use that community. So you need to remember what that is. So this is the only parameter you need to specify here on this file. But what I've done is I've also specified disk / because I want to monitor the / partition disk, and I will show you that later on. Like I said, the rest of the information here you can pretty much just leave it the way it is. Nothing really needs to be changed. I do want to show you here. In my case, I did change some things, but you don't have to change anything on your system. Just set the community and tell it to monitor disk / and that's it. But you could send some security measurements here. So what I've done is I created an entry here for my local host, and also an entry for the network 192.168.119.0, which is our private network. And I've given it the community name, which is CSE570E. Then I've created a group for both of these, and here basically is where I can give access to that group. Okay, so and then here I'm setting it where I want to be able to view all the MIBs. And MIBs are management information bases, which are text definitions of each of the OIDs. Um, the OIDs are just like are arranged in a structure for managing the information that is part of the tree that lists all the different um, MIBs that you can use in Linux under SNMP. So basically, hardware vendors specify these OIDs, which are just numbers basically. And inside each of these OIDs, you have these management information bases, or MIBs, which are just like the definitions of each of the OID branches. And then you can actually query these using the SNMP protocol, and I will show you how you would do this. Again, all this information here you really don't need. I've set it so that I can secure my SNMP instance a little more and only allow access to hosts on this network, for example. Okay, so I'm going to exit here, and I'm going to show you how I can use some of the commands to query the SNMP information. So I want to start SNMP, so ATC service SNMPD restart to restart the SNMP protocol. Okay, now there are two commands that come when you install the basically the RPMs that you need to get the clients to query the SNMP service are net SNMP. So RPM minus QA pipe grep net SNMP. Okay, these net SNMP utilities are the tools that you need. Okay, and there are two basic ones that you will be using. SNMP get is for querying the individual OIDs, and SNMP walk is for obtaining the contents of an entire MIB. So let's take a look at this. So I could do SNMP walk minus V because it's version 1 minus C for community CSE 570E, and then I'm going to query the local host. You could use an IP here if you wanted to, but I'm just doing local host, and I'm going to query for system. Okay, so basically what this did is going to show me the contents of the entire MIB, or management information base. So these are all the possible MIBs that I have available. Okay, now I did that for system, but I also could do this for interface, which would be the network interface information. So this is all of the network stuff. These are all the network MIBs. Okay, now if I wanted to query one specific individual OID, I could do an SNMP get. And let's take a look at here. Okay, so for example here, this is the MAC address of the network interface, and I'm gonna take this string here, the IFI, so I could do SNMP get minus V1 minus C CSE 570E localhost, and now if I query that, I basically get this information here, which is the MAC address. But see, there's a lot more of these defined here There are counters, different counters that look at different things as far as the network. And what you need to do to figure out what these are is look at the actual definition, which of these, which is part of the MIB text file. And these are found under user, share, SNMP, MIBs, UCD, as this is one, for example, okay? And this basically lists all the MIBs available and what each of them are. And hardware vendors provide these for you, and they tell you exactly what they are. So once you know what they are, you can look at what you're looking for. See here you have this one here called mem cached, and you know that's the total cache memory. Okay, so let's take a look at another one here. You CD user share might be VI. Let's take a look at the TCP IP1. Now the one that I queried was if fizz. Okay, I was gonna look for physical address, but again here the description tells you exactly what it is. Okay, the minimum value pertaining. So if you want to find out what each of these are, just look at the definition and this will tell you. Okay, so let's take a look at this one, for example. TCP maxcon, the limit on the total number of TCP connections the entity can support. In entities where the maximum number of connections is dynamic, this object should contain the value -1. Okay, so then you can run this command. I hope this is gonna work. I don't know if I have that loaded. There's no such variable there, maybe. Okay, well that one didn't work, but basically you get the idea. These are the definitions are in these files, and you could actually use the get command to actually get the value of that particular MIB. So like I did before, I can run this SNMP get, and I know that I get this for the MAC address. So if I do if config -a, I can verify that that's the MAC address of my ETH0, and it is because it matches. So again, this I use SNMP basically to get the information on the network interface. Okay, these are also found. These particular values here, the RX bytes and the TX bytes, can also be obtained using SNMP. Now, the question is, what do you do with all this information? Okay, it's out there, but are you really going to query each one of them and look at them, and how do you keep track of all this information? And a very nice tool for doing this is the MRTG, which is the multi-router traffic grapher. And all of MRTG does is produces graphs of different statistics, and it displays them on a web page. And by default, MRTG maps the inbound and outbound data throughput. So it basically takes these values here and grabs them by default. But you can make MRTG basically graph anything. Okay. So let me show you what I have done. If I go to etc, first you have to install the MRTG. So rpm-qa pipegrep MRTG. You can see that I have MRTG installed, and once you install it, it does two things. It creates etc MRTG directory, and here's the mrtg.cfg, and this is basically where you tell it what do you want to graph. So if we look at this file, here I'm telling it the name of the particular MIB that I want to graph, okay? And here I'm telling it to connect to the local host using the community CSC 570E. The rest of the stuff that's here is basically used to actually do the graphing, but the actual target is the particular SNMP MIB that I'm looking at. So I'm doing this %1, and since I put slash on my SNMP conf, it knows that that's my first uh, um, disk that I'm querying, because I could put other partitions that I want to query, and the only thing that it would change would be the second one that I defined would be 2 and 3 and so on. Okay, so if I go to the top of this, I can see here I want to graph some CPU information. Here I want to graph memory available. Here I want to graph percentage of free memory, which in this case is actually a calculation of different SNMP values. Okay, so basically there's a cron job in etc cron.d that runs every 5 seconds, and it runs basically this mrtg command to go out there and execute this file and store the information that it gets by querying the different SNMP MIBs that I've specified on the mrtg.cfg file, and it stores those in these files, and then there's a web page that actually reads those files and displays them. So the first thing that you need to do is uh, put your mrtg.cfg in the etc mrtg directory, and I've already done that. And for the assignment, I'm providing you one of these already, so you don't have to create that. Then you need to run the command env lang equals c, which is just specifying uh, an environment variable. And then you want to do user bin mrtg etc mrtg.cfg, and this is basically the command that cron job will run every 5 seconds to create uh, the the data by looking at the CFG file. So it reads the CFG file, it pulls all the SNMP statistics that you've asked for, and it stores them in these files. And then the first time you run this command, you're going to get some errors, so you need to actually run it 3 times in a row, and after that you'll see that it works. So run that 3 times, and then cron will run it after that every 5 minutes. And then the other thing you need to do is use the index maker utility, and mrtg comes with this index maker tool, which basically allows you to create a web page displaying all the information that you've specified you want to compute in the mrtg.cfg. And the command line for this command is index maker minus output equals, this is the directory where you want to save the HTML file, the index.html. So in our case it's var ww, which is our mrtg mount point, index.html, and then the mrtg config file, which is etc mrtg.cfg. So index maker minus output equals your mount point for mrtg, which is var www.mrtg index.html, and then etc mrtg cfg, which is your mrtg config file. So that will create an index.html by reading this information here. So once you run that, you can go to var www.mrtg and see that there's an index file. With all the information, and then the rest are just the pictures of the things that it's going to display. Okay, so every 5 minutes it goes out, creates these log files with the information, and stores the information there, and it also creates these PNG images displaying the data, and HTML pages as well displaying the data in the log files. Okay, so you really don't have to set that cron job. When you install MRTG, it creates that cron job already, and it puts it there, and it starts doing it by default. The only thing you need to do then is to vi the etc http conf.the mrtg.conf, and by default it only allows you to view these statistics from localhost, so you want to allow from all so you can view them from anywhere, and then restart Apache, and then you can actually go to the name of your server, which for your case, once you configure this, you would put localhost, you would start X, so you would go around level 5, you would open Mozilla, and then after that type localhost /mrtg, and you can see that it will begin graphing. So here, for example, my CPU utilization was low, but then it peaked. It went up to almost 90, and then it came back down, so that's a good sign. Memory wise, new TCP connections, I'm averaging 3 per sec per minute. Okay, so basically I just started MRTG, so it just started gathering these statistics, but it will keep doing this on a continuous basis, and then if you click on the actual thing, it will show you these by daily, weekly, monthly, and yearly basis. So the nice thing about this is that you just let it run in the background, and it computes this and stores all this information, and if you ever have, you can monitor these on a daily basis and see how your systems are performing. And also you can see that if you have any problems with your systems, or they're slow or whatever, you can see what the problem is. You can see if it was CPU, if it was memory, if it was the network, or too many connections. Here's one for disk. You can see how much storage your disk. So it looks like my slash partition, it's about 80% full. So you can see when you get over a certain limit that you need to add more disk space, and that's how